Example 1. Two-tailed test for proportions. A marketing company claims that it received 8% responses from its mailing. To test this claim, a random sample of 500 people were surveyed with 25 responses. Test at the 5% significance level. Part A, state the null hypothesis and the alternative hypothesis. When you're dealing with these type of questions, you need to ask the two questions. Which situation you're in, that's the first question. Second question is which testing are you dealing with? The first questions that you need to ask is which situation you're in. And how you know which situation you're in is because when you look at the numbers from the questions, you see the 8%, so you know this is the percent. And you also see the 25 out of 500 people responded, so that you need to know that there are two numbers and you need to divide it to get a percentage. So therefore, you know that these are percentage. And because you know these are percentage, you know these are proportions. So that's how you know you're in a situation of proportions. And why that is important is because once you know which situation you're in, once you know you're in the proportions, then you can use the formula to calculate the test statistics, to calculate the critical value, and the p-value. So you're going to use the Z statistics proportions to calculate the test statistics for proportions. You're going to use the critical value norm.s.inv in Excel to calculate proportions, critical value. You're going to use the norm.s.dis to calculate the p-value for proportions. So that's the first question, which situation you're in. The second question you need to ask is which testing you're dealing with. And how we know which testing we're dealing with is because when we look at the questions, the first two sentences, we're trying to prove that is the response 8% or not. That's what we're trying to prove. So is it 8% or is it different than 8%? That's what we're trying to prove. So once we understand what we're trying to prove is it equal to 8% or is it not equal to 8%? Then we know that we're in the two-tailed testings. And that is step 1, asking the two questions, which situations and which testings. Step 2 is stating the null hypothesis and alternative hypothesis. And when we state the null hypothesis and alternative hypothesis, we start with the H1. H1 is what we want to prove. We want to prove that is it 8% or not? We want to prove that is the population proportion, the pi, equals to 8% or not. That's what we want to prove. We want to prove that is different than 8%. So that's why we have H1, the proportion, the population proportion, pi, does not equal to 8%. We want to prove that is different than 8%. And before we prove that is different than 8%, we have to assume that the H null is true. So H null is the opposite, right? So H null is pi equals to 8%. We have to assume that the population proportion is equal to 8%. That's H null. And H1 is what we want to prove. We want to prove that is different than 8%. And that is step 2. Step 3 is calculating the test statistics, the critical value, and the p-value. The first value that we're calculating is the test statistics. And because we know that we're in the proportion situations, when we calculate the Z statistics, we use the formula p minus pi divided by square root pi times 1 minus pi divided by n. And p is your sample proportion, pi is your population proportions. And how we calculate p, the sample proportion, is the 25 over 500. Pi is your population proportion, which is 8%. The reason it is 8% is because of H null. What H null states is that population proportion equals to 8%. And because we haven't proved anything yet, we have to assume that H null is true. So we have to assume right now, we need to assume that population proportion is equal to 8%. So that's why we're putting that into the formula. Pi equals to 8%. And then n is your sample, and sample is 500. And once we substitute all these values into the formula, we're going to get negative 2.4727. So that's the first value that you need to calculate, test statistics.